Thanks again for joining me. As promised, we're going to get working on the user services signup functionality. We'll also get around to working on the repository layer and adding a Postgres Docker container so that we can connect the layers and test creating an actual user. But these are just words, so I created a diagram to zoom out and see what we've done and what we're going to be doing in the following tutorials. So here's a diagram of the progress we've made on our account application so far. First, we worked on this me handler. It receives a user's ID from an authorization token. The user ID is extracted from this token in something called middleware, which we've yet to create. This get handler reaches out to the user services get method, which in turn reaches out to a user repository find by ID method, which we've currently only mocked, but will implement here in today's lecture. We also have this signup handler here. We worked on this handler in the last two tutorials, if you can recall. And if we quickly reopen the handler in Visual Studio Code, you can see that it binds some data. It calls a user service signup method with a partially created user with an email and password. It checks for errors, so if the user is signed up, it then reaches out to a token service, new pair from user. Going back to the diagram here, we have these lines showing the new pair from user and sign up, and this is what we want to work on today, is this sign up method in the service layer, and also creating a token service and working on the new pair from user method. This does not reach out to any repositories, but the signup method will reach out to a user repository's create method. Now, how does this user repository store users? It does so by connecting to a data source. So this repository, user repository at least, will have a connection, as you see on this line, to a Postgres database. So our concrete implementation of a user repository will be called a PG user repository, meaning Postgres user repository. So furthermore, we need to actually create some sort of instance of a Postgres server. And it's been a while, but you might recall that we have a Docker Compose YAML file inside of our project. So if we go to the root of the project, you can see this Docker Compose YAML file. So what we'll do here is add a new key and container based on an image for Postgres. And this will be a pretty standard copy and paste dev setup for a Postgres container. So don't worry, that's not too complex. We'll just tack that on at the end of this tutorial so that we're ready down the line to inject this connection to this database into our application. So today we're going to be following this line down to Postgres, and next time we'll be creating this new pair from user, or a new token pair from user, as this involves setting up some secrets and some keys. There's a little bit of infrastructure and explanation involved, so it would be a lot to do that in one tutorial. After we have the new pair from user and signup flow working, we can begin to inject this dependency flow into our actual application so that we can make calls from an HTTP client, which could be Postman, which I'll be using, or you could manually do it via curl or whatever your preferred HTTP client is. So we'll actually create a connection to Postgres, the Postgres container, that will be injected into the user repository, which will be injected into the user service, not the signup handler, which will be injected into the handler layer, and we'll also inject this token service into the handler layer. All right, are you intimidated yet? Maybe not. Maybe you're a lot smarter than me. But after these pieces are in place, I think we'll have some of the most difficult functionality of this application in place. So from there, it will be more focused on logic. We will have to, for example, inject a Redis container into the token service, but this will make more sense after we've done it one time. So we're back in the project, and the first thing I want to do is add an expectation that the user repository should have a get method. And we do that via interfaces, if you recall, and we have this model folder and our interfaces. So in user repository, let's add the definition of a create method. So this create method takes a context, and then it also takes a reference to a user. And if the user is successfully created in the repository, it will modify this user reference. And if not, if there's a problem, it will return an error. So if you save this file, you might be getting some sort of problem, and I hope you do. That would mean you have your editor and GoTool set up well. So we cannot create or use mock user repository as a user repository, meaning this model user repository, because it's missing the create method. So if you recall, we had to mock this findById method when testing the me handler. So let's go into mocks here. We need to look at the mock user repository, and we need to implement a get method. So this is similar to all the other mocks. It's very similar to findById, but our get method can only return an error, so we'll be having a statement like this one. All right, so here is our create method, and hopefully your errors will go away. I won't go over this, but you can pause the video and take a look, or look at the GitHub repository if you need to stare at this and think about it. The next thing I want to do is get working on the user service signup method. We already scaffolded this out, but we just put a panic inside of the method. We did not create any implementation, and we're going to work on that implementation right now. So back in our project, let's go to not this user service. Oops. We want to go into the service layer, the actual implementation here for user service. And here is our signup method. So let's add some code and go over it. All right. So basically we reach out to that user repository create method that we just defined in our interfaces. And we check if there's an error and we return it if there is. Otherwise we return nil. So that's pretty easy, right? Well, not so fast. In general, we don't want to store passwords as plain text because that would make life really easy for any hackers if our database is breached. A few tutorials back, I said that we'd have to add more complexity and logic to some of our service methods, so here we go. We're going to add some functions for encrypting a password, and then another function for comparing a supplied password, like when the user logs in, with a stored encrypted password. And before we do this, let me tell you or remind you that I'm not even a cryptography novice. I'm below that. But I'm going to add some code based on what I found out there for generating what's called a SALT and a hashed password via the scrypt algorithm, which is built into a Go library. I'm probably going to use some terminology wrong, so apologies in advance for you cryptography experts out there. Leave a comment or go tweet about it. So instead of adding all of the password logic in here, we're going to be reusing some of it. We'll only reuse it in the service layer, so I'm going to create a file inside services. Let me go back, service here. It's not services, service. And create a new file called password.go. And I think I just said filed. That's impressive. I am gifted at scrambling words. I'm not even that old. I can't wait if I make it that long to see how I sound or hear how I sound. See, I can't even get that right. All right, so I've added the package service and done some imports from Go standard and experimental X libraries here. And let's just go over some of the details of what's going on in these. Again, I'm not an expert, so forgive me if I mess up. And I'm apologizing more than a Canadian. Apologies to the Canadians as well. Alrighty. So, the first thing we do is create a 32-byte salt, and this is just an empty byte slice here. And then we read random values into that slice and check for an error. And with that random salt, we can then create something called a key or a hash using scrypt. And so we take the supplied password, like when the user signs up or signs in, and then we supply this 32-byte salt. Next, we have something called cost parameters here. And what these are is basically a trade-off between computational power required to encrypt or hash your password and the difficulty of stealing the hash or key with brute force attacks, meaning being able to get the hash function or this random thing created here. I may have that wrong, but more or less, it's a trade-off between difficulty of breaking your password and the computational power to create that. The 32 here just relates to the 32-byte salt and size of the hash. So in order to check a user's password when they try to log in at a later date, we'll need the same salt that we just created here. So that's this. So what you'll see a lot of users do, or a lot of application designers do, is append the salt to the actual hash password. And so that's what we do here. I use an sprintf with a period in the middle here and append the salt to the hash password. And in both cases, I'm encoding these byte arrays to hex strings, and that's what this hex encode to string method is. And so then we return this. We also have a function that does the reverse, and that is compare password. So we split the password. This would come from our database, and we split it on the period to get the hash password and the salt. And then again, we decode that salt into a 32-byte slice here, as you can see. And we check if there's an error decoding that string. Hopefully not, since we encoded it. And then we do the same thing we did before. We use scrypt, and we take the supplied password with the salt that was extracted from the database here, and make sure that it matches the hash password. So this is the hash password from the database, and we make sure the supplied one passed with this, or salted with this same salt, produces the same value. So that's how we compare a password when a user logs in. So finally, we need to use this method, or not the compare password function, I should say, but the hash password back inside of our user service. So let's do that. Let's go to user service. All right, so here I'm in user service, and I've added a password, and I hash the password provided on u.password. And then, if that's successful, if there is not an error, if there is an error, we log and return an internal server error. Otherwise, we're going to mutate the password with the newly hashed one and call our user repository create method with this updated user. Now, I put a comment here. It is a little weird to mutate this password. I had previously in this method of signup provided a username or email, user email and password, but I decided that was getting to be too many parameters, and what's the max parameters you should supply to a method, and decided to go with user. I don't think I like it very much, but we're going to stick with it so I don't have to change a lot of code. And then I just added some comments here. We may or may not get around to this, but let's say we do have a microservices architecture, then here is where you could call your events broker, whether that's Kafka or Cloud Service or something, and you could publish an event to say your user was updated and basically send that user to some sort of subscription service. So that's it for the service method. We'll be able to test it by using the user repository mock we updated towards the beginning. So now that we've added the signup functionality, we could do two things, and I already said earlier what we're going to do. We could either work on this new pair from user, but as I said, that requires a lot of details. So I just want to show you an example of an actual concrete implementation of a user repository here and how it can access libraries for working with Postgres. So back in our project, we need to create a new folder for the implementation of our repository. So I'll say new folder, repository. And then in here, I want to add a file called pg user repository to make it clear that this is a Postgres implementation of a user repository. You don't have to call it that, but it adds some clarity, as you might have another database, a MySQL, a MongoDB, whatever it might be. So let's add some initialization of this repository. So right now, I'm just showing the package repository, and I want to, before I do my auto imports, I want to show you this github.com jmoiron, I don't know how to say his name, sorry, SQLX package, which basically just provides some utility methods on top of the standard Go SQL library, and we'll see one of those methods soon. We then create a PG user repository struct, which can take a connection with this from this library. So that's what SQLXDB is. And then we continue using this factory pattern by creating a new user repository function, which returns a model.user repository. So let's save this and hopefully get some auto imports. I guess just one import for the model layer. And you'll see here that our user repository does not implement the create method, which we defined earlier. So we need to implement that. Also, I just wanted to say I've done something wrong in the previous tutorials. If we're going to use this factory pattern to return, an abstract idea or an interface, this type here should really be package private. So it should maybe be like a lowercase p here. So we'll fix that in a couple tutorials at a good stopping point. So here is our create method. And you can see we create a basic SQL query to insert into a users table an email and password column with some placeholder values. And then we're going to use this returning star to return back the value of the row that is inserted. And that's why you can see here, we're going to use a utility method on the SQLX library to execute this query and then fill in the email and password as these placeholders you see here. And it seems strange that we're inserting, but we're using a get method. But what that allows us to do is take these return values and insert them into use. So for example, our database should take care of handling, and we'll do this later, the creation of a user ID as a unique ID. So if there's an error here, we're going to check if that error is a unique violation, meaning that that user email already exists. So we're going to enforce that this email is unique. And if that's the case, I want to return one of our custom app errors called new conflict and say that this user email already exists. If not, we'll just return a generic internal server error of 500. While we're at it, we'll also implement this find by ID method. Actually, we have to because we've defined it in the interface. And in this case, all it does is select a user based on a user ID, and we execute a get method on this SQLX library. So hopefully that makes reasonable sense. Let's move on to testing this user service. That user repository functionality was somewhat of an aside, but it will prepare us to better link up the application layers later on. So let's go back to our user service here, and let's add a couple of unit tests for the actual user service, which we're looking at right now, the signup method. So let's go into user service _ test. And I'm not going to go into this into detail. You can check the code on GitHub or pause the video if you want to see more of what's going on. So basically, we're just adding two tests, a success signup case and a failure. And one thing that I will say is that I create a mock user repository, and we're going to call that create method that we just mocked, and we actually created a concrete implementation of this. And an interesting thing I found out, which we could have done earlier, is you can use this run method with a callback function, and you can modify the arguments that you provide to the create method. So the create method is provided with a mock user, and inside this is the second argument, this is the first. And so we can say get the args1, it's 0 indexed, cast it to a user, and then assign the user ID. And so then that's just a way to more mock the real implementation. I don't know if it changes the actual test much, but we can assert then that, okay, a user ID was assigned and that there was no error. Before doing this, I might have just asserted that there was no error and that the method was called. I think the error is pretty self-explanatory. We just create a mock error to return, and there you go. Let's run these tests, even though I haven't gone into them in detail, and we'll do that as always with go test -verbose, and then we'll run the service layer tests. And you can see the test signup is passing here for both cases. Finally, this video is getting long, but to be fair, the next two will probably be long as well. I thought to do all three of these in one video, and as I started working on this, I quickly realized that was not a good idea. So To finish, let's do a little work on this Docker Compose file. Now, I don't know if you remember, I had some weird folder organization here to work with VS Code workspaces. Hopefully it's not too confusing, but this memorizer folder is the root of our application or our project, and this account here corresponds to this account folder. It's kind of copied. So let's go to the root of the folder, the Docker Compose, and let's add a Postgres auth container. That's because we'll be using Postgres for our word memorization database as well. Or what I mean is, we'll have 2 Postgres containers, so I just want to name them uniquely. So let's go to this level and copy some. And copying always has issues in YAML for some reason. And let's just make sure our tabs are indented correctly. All right, so we have this Postgres auth container. I basically just set the password to password. We're going to use the standard port mapping and a command to get this going. But also notice that we're going to use a volume called pgdata_auth. So we'll need to create a volumes key at the bottom of this Docker Compose YAML file to be able to use this. So let's scroll down to the very bottom. And at the root level tabs, we'll add this volume pgauth. So again, this needs to be, wow, someone's slamming a lot of doors right now. So this needs to be at the same level as services. So our volumes is set up. Now, one other thing we can do here is we can modify our account container here to make sure that it knows to depend on the Postgres auth. So basically, if there's a problem booting up this Postgres auth container, then I think it will stop the account container creation. So towards the bottom of this, where we've declared some volume for our account application, let's add a depends on key with an array and add Postgres auth to it later. This will also end up depending on a Redis container, so we need multiple keys here. So let's save this and let's change directory. Someone's opened and closed the door like 15 times, so you're just going to hear it. So let's go back into the root of our application memorizer and let's make sure this Docker is working. And there's a chance I'll have forgotten something, but let's run Docker Compose up. And it's going to run. It's going to add another 20 seconds to your video and your life. All right, that's good. The Postgres auth seems to be starting up here and is ready to accept connections. That's good. I could probably change the log levels with this. Maybe I will later. We get a lot of Postgres logs here. And then our Gen account started up. Now we're not actually connecting to make sure that's working yet, but at the very least, we have both of these containers up and running. I'm going to make an abrupt stop here, but thanks for joining along. Next time, we're going to work on creating our ID token, and that will also serve as something that people call an access token for access to our organization or domains applications. And then we'll also create a refresh token. We'll describe the differences between these two in the next tutorial. So until then, cuídense.